Hello everybody, in this show I will present to you the effects of the intrinsic characteristics of light-dependent resistor sensors on optical sound tracking applications. Since the Industrial Revolution, human activities have generated large volumes of greenhouse gases, resulting in climate change which has caused global warming. Renewable sources of energy are the only effective solution to solve global warming, climate change and energy crisis. For this, many solutions can be suggested. One of the most abundant renewable sources is solar energy. It can be exploited to produce thermal energy by using solar concentrators such as Fresnel concentrators and parabolic collectors. The aim of this work is to study the effect of dissimilarity on intrinsic characteristics of the LDR sensors on sound tracking accuracy and propose a solution to avoid the caused side effects for solar concentration applications. Our mission is not only to create a 3D innovative design or a working prototype, but to create a long-life finished product with a high efficiency, reliability, and quality. The final product must have a high local integration rate in order to promote the Made in Morocco brand as an effective alternative to existing products. Our vision is to create an innovative solar water heater that combines the advantages of the most widespread technologies that exist in one product, and create a versatile and scalable product that may be used also for solar power plant like solar concentrators used in Norway's project. In order to perform this study, we build a metallic structure that allows to the Fresnel mirrors to track the sun on its azimuth and elevation axis thanks to two electric motors. In addition to that, an LDR holder was made using a 3D printer. It is crossed by two walls in order to create shadows on LDRs. Each wall has on its opposite side an LDR that sends measured luminescence value to a microcontroller. Then a software processes all received data and decides in which direction motor should turn. In order to study and compare the intrinsic characteristics of LDRs, it was necessary to build a test bench that allows to select 4 LDRs accordingly to the luminous resistance characteristics. This black box is made from an opaque material and painted with matte black color. It contains a halogen bulb lamp with a dimmer circuit to vary the light intensity using PWM signal. The LDR is facing the light bulb and connected to a microcontroller in order to read returned values and send them to a computer using USB cable. Concerning tools, a pyranometer is used to assure that the test was done under the same condition and there was no cloud during the test period. In order to have a way to control the sound tracking efficiency, a thermocouple is placed in the middle of the absorber and connected to a data recorder to measure temperature every 90 seconds. An efficient sound tracking system should keep the sun rays concentrated on the absorber surface, which means that the thermocouple should indicate a high and stable temperature during the all test period. So the followed methodology to do this experiment is to start early morning by cleaning mirrors and absorber, perform a calibration if needed, start tracking, start pyranometer and thermocouple recorders. And at the end of the day, stop thermocouple and pyranometer recorders, analyze recorded data, check if there is no cloud during test, and finally validate the test if everything is okay. The first experiment consists of using 4 random LDRs. We can see on the top figure that there was no cloud during the experiment, and in the bottom figure the thermocouple indicates a low temperature around 33 degrees, which is the ambient temperature, which means that there was no concentration on the absorber. The second experiment consists of using 4 random LDRs, but this time with performing a calibration. We can see on the top figure that there was no cloud during experiment, and in the bottom figure the sound tracking was good during the first hour. The temperature was around 83 degrees, but more the time passes, more the offset is important, more the sound tracker drift and focus sunrise somewhere else than on the absorber surface, which explains the temperature drops until it reached the ambient temperature at 4 p.m. We check the two LDRs previously used for elevation axis and trace their characteristic curve using the black box. The result is two curves with an average dissimilarity of 5.5%, which explains that there was happening during the first and second experiment. After testing 26 other LDRs, we get 26 curves, and we can notice that some LDRs coupled can have dissimilarity up to 23% and average dissimilarity of 3.7%. After analyzing the curves, we can select two LDRs that have the minimum dissimilarity of 0.06% and reinstall them on the sound tracker in order to reperform the two previous experiments, but this time by using the selected LDRs thanks to the black box. The third experiment consists of using selected LDRs without calibration. We can see on the top figure that there was no cloud during the experiment, and at the bottom figure shows that the sound tracking was good all along the test period. The temperature is kept greater 2.5 times than the ambient temperature and varies in function of the sound power. It reached the peak temperature of 84 degrees at midday 30, which coincides with the peak of sound power, then started to decrease until it reached 65 degrees at 4 p.m. The first experiment consists of using selected LDRs, but this time with performing a calibration. The top figure shows that there was no clouds during the experiment, and the bottom figure shows that the sound tracking was good. The temperature is maintained stable depending on sound power, and we can also notice that there is no significant improvement in efficiency after performing calibration for selected LDRs. This study allowed us to know the effect of dissimilarity between the intrinsic characteristics of LDRs and propose a solution to better choose them in order to meet the requirements of solar concentration. The verdict is there is a huge dissimilarity dissimilarity between two LDRs chosen randomly. This difference can reach 23%, what results in a bad sound tracking from solar concentration system, even if an offset calibration is performed at the beginning of the experiment. Thanks to the use of the black box, which allows to sort LDRs depending on their intrinsic characteristics, this technique results in obtaining two LDRs with a dissimilarity less than 0.06%, which means that at any moment of the day, the two LDRs measure the same value with a 0.06% of reading errors, which allows to track sun during all the day without any drift and also without need of an initial offset calibration. Thank you.